Hello dear students. So today we are going to see hands-on on backpropagation algorithm. So this particular example is going to demonstrate a single layer neural network for a simple linear regression problem using backpropagation. So what I have taken here is only a single neuron and a single input feature. So we are going to implement both forward and backward passes for training. So for your information, again I am telling you, once you take the input, you apply linearity, you apply logic activation function logic, and then you produce your predicted output. This is nothing but your forward pass. Okay, and then once you have got your predicted output and your original output difference, you will be calculating your loss function. If it is a simple linear regression problem, we will take mean square error. Otherwise, if it is classification, then we will go for cross entropy loss function. So based on your application, you will take a suitable loss function, and then you try to implement your gradient of your loss function based on the parameters of your weights and biases, and implement gradient descent algorithm to to update your weights and biases so as to get an optimal solution. So this entire thing is nothing but your backpropagation algorithm, correct? So this is going to be a very simple type of program that we are going to see. You just have to make sure that you understand the concept. Coding is very simple here with respect to your genre. Now importing numpy, and first we are going to define our activation function. Since it is a very simple linear regression problem, I have taken up here sigmoid activation function, and I'm going to find out its derivative also. So I am defining a sigmoid activation function, and you already know the mathematical equation for a sigmoid function, which is 1 plus e power minus x. So that's what I have defined here. I have defined my sigmoid activation function. Once I have defined my sigmoid activation function, you know the derivative of the sigmoid also, sigma into 1 minus sigma. So that's what I am defining here. Now I am defining a class of neural network, and where it will take the parameters as input size, hidden size, and output size. Here I begin with just initialization of weights and biases with my random values. Generally you can take it as the bias is taken as 0 and weights are taken as any random values. So that's what I have taken here. Weights are random and bias is 0. Similarly, input layer and hidden layer bias, uh, hidden layer in weight, hidden layer output layer weight and bias, these are all initialized here. Once I have initialized my parameters of weights and biases, now I will move a little bit, and I will go for defining my forward pass. So what I am doing inside my forward pass, I am simply you know I want to go for first the linear model. That's the reason what I am going to do here is I will multiply my weight with my input, and I would do a plus to the bias. So that's what I'll do to obtain my linear model. And once I pass this through my activation function, which is sigmoid here, I will get my output. So that's what I am doing here. I am taking this linear value, I am passing it through my sigmoid function and getting my output. And again the same thing, I am going to finally get my uh, final output by multiplying my hidden layer output with my hidden layer weights, and again it's bias. So this nested value of my network, you already know it when I have defined it properly, the neural network. The same thing I'm just doing here. Now once I got my final output, I will again go and define a function wherein I can implement my backward pass, which is my backpropagation algorithm. So you all know that for the backpropagation algorithm, what you require is to find out the difference between your predicted value and the actual value. Since here the predicted value I called it as output, I am going to find out the difference between my original value and my predicted value, and I am going to find out the error, where I am calling this error as delta. So what I am going to do here is, I am calculating this delta with respect to again the weights of my hidden output, and you all know I am going to apply here the chain rule. Okay, so this hidden error I am going to multiply with the derivative of my hidden output, right? I already explained you the chain rule, so the same thing I am going to apply over here. Chain rule I am applying here, and after I have done that, I would try to fix it and update my input hidden values with respect to uh, my the value of my gradient that I receive it over here. Okay, so once I am done with that, what I am going to do, I just update my bias values and weights values, and I'm now again creating one more function for training my particular model. You all know that I have to keep on updating these values of gradient descent unless and until I get back a optimum value. So for that I have to give the input output and the number of epochs or the iterations for which I feel that I may get my optimum solution. So that's what I am doing over here, and once I get that, now I start my data set. I am simply choosing a very small data set. You can take up any bigger data set and work with the same type of model. Now I've chosen a very small neural network as well. Just the aim here is to understand the concept of how we are building a forward pass and a reverse pass or a backward pass. Now, creating and training a neural network, I am just randomly initializing few input sizes and hidden sizes and output sizes, and I am creating a neural network. I have fixed my epochs to 10,000, and that's what I do. Within the length of my input x, I perform forward pass, and the results I store in a variable called prediction, and then I try to print them up. So this is what I am going to do, and stop it over here. Now suppose you want to extend it. Suppose I want to extend it to a 4-layer fully connected network using back propagation. I have given here some dimensions. Suppose it has got 2 input nodes, 3 hidden layers with 20, 50, 25 nodes respectively, 2 output nodes. So we are actually doing this for binary classification. So how do I go for? So the process remains the same. I first define the activation function, sigmoid and sigmoid derivative, and now I'm defining my class of neural network. Same thing that you have seen, like I am defining the hidden sizes and initializing the weights and biases. As usual, weights will be all random, biases will be zeros first. Now within the range of all my hidden layers, again I update its weights. I initialize the weights to be random, and all I update and initialize all its biases to be zeros for all my hidden layers. And again I define a forward pass wherein I have got some x number of input layers. Then this is a more generalized model, so x number of input layers, and then again based on the range of how many hidden layers that I have, I am going to find out w into x in plus b, same linear relationship, passing it through the activation function and getting the output, and returning the whatever the layer output you get for the first layer serves as an input layer to the next layer. So that's what I did over here. Now again in the same strategy, after I have defined forward pass, now I'll define the backward pass. So you are going to calculate the error, apply chain rule, and calculate deltas for all the hidden layers as well. Okay, so I guess it is very self-explainable type of a code, and already I explained you how many number of hidden layers and all what you are going to take. I guess this is doable. Once you have done that, you will update your weights and bias in your backward pass, and you write one more method for training your data. You write second method for predicting, and then you just take a simple data set with one hot encoding, create and train the neural network. Of course here now I am specifying whatever sizes of the data that have been mentioned in the start of this case study. You can change them as per your requirement. Make sure the learning rate is low. It is actually 0.1. We already try to take it a very small value so as to we don't skip our minima too fast. And epochs I have chosen here 10,000. Simply I'm calling my class of neural network and training it, and then I'm trying to print the predicted value. So I give this as a task to you. You try to work on it. You can take up some bigger data set as well and try to do. So this is it. Try to check the output for yourself and get back to me if you have got any doubts.